All right, let's go. Get some water. All right, hello everyone, December 29th. I just finished eating, got my water, need to turn my brain on, and let's do this. Okay, so based on the new design, I know I have solved this problem before. Okay, I've solved this problem before. 2 times. Huh. Yeah, I actually don't know about this. It's I mean, I know because I also upvoted it, so it's okay. It's okay. All right, what is this? Give integer 0, 1, 0, 1, low and high. We can construct a string by starting with an empty string and then at each step perform either of the following. Append the character 0 times. Append the character 1 time. This can be performed any number of times. A good string is a string constructed by the above process, having a length between low and high inclusive. Return the number of different good strings that can be constructed satisfying these properties. I seem to seem to remember this one. So basically you have repetitions as allowed. So each operation is either add 0 number of zeros or 1 number of ones, and you can perform them any number of times, right? So for the first one, low 3, high 3, so the size is 3, and I can perform them 1 time, so that's 8. Right, the base stage is 0, 0, 0 all the way to 1, 1, 1. Right, and you can do 8 of them. The second one is low is 2, so we can do 2 characters or 3 characters. And the 2 characters or 3 characters, right? And for 2 characters, I can do 1 once. That's it, like 1 once, or we can do 0, right? And for here, I say I can do 0 at a first, and then it's the same problem as this. So this actually we have 2, and then if I do 1, 1, because I do 1, and I can only do 1, so it will be 1, 2, 3, 4, 5. It will be 5 different. So there's some repeated problems, for sure. So you should start from lower numbers, right? You should start from lower numbers, get from the low, and decide how many different ways you can do low. You can do not just low, just given a length, you need to figure out how many you can do. Oh, given a length, you say. Why given a length? Why given a length? We should start from 1, right? We should start from 1. So I say given 1, how many different ways you have? For this you have 2, because you can do a 0 and a 1, right? And then we say if we have 2 positions, how many we can have? And then you can say, okay, I can do the first. We set the first one is, something, and then this is a 1. So you can say if we go 0, then we have 2. And that's a 2 plus 2, that's a 4. And then we have 3. So this one I have 2. This has 4. So 2 times 4. So that's why it's an 8, right? So if we go for the other one, I think we can apply the same method. For example, 1, right? Length is 1. I have only 1 solution. Length is 2. I can break it down to 1 on 1, that's 1. Or I can do 2 by itself, right? I can do 2 by itself, so it's 1, so that's 2. And the length is 3. So I can do, because I can either choose to do this or do this. So if I do this, 1, then I have this 2 left. So I have to times 2. Or I can do 2, and I have 1 left. So I have 1 left. So plus 1, that's 3. And then 2 plus 3, it's 5. So basically, right? Basically, we'll go from 1, and for each one, you can decide if I want to apply 0 or apply 1. And if 0 and 1 is a big value, and I cannot do not just a 0, not a 0. So we just, actually we don't even start. We start from the smaller of the 2 values, right? From the smaller of the 2 values. And then we'll record that is a 1. Oh, that is a good question, okay? That is actually a good question. Do we use a DP array for this? And I think the answer is yes, we should. Should we not? Think, dummy, think. I think we should. We create an array of size high, okay? High plus 1, basically. Set everybody to 0. Then we start from the smaller of 0 and 1, and we do that, and we yes, because 0 is basically that is interesting. 0 should be 1. Like, how many ways you can make length 0 is 1 way, because in that way I can say the current length, we can call it current, right? We can minus 0, right? We can minus 0, this is the remaining. And now we can call dp this to know how many different ways. And then we'll do this plus dp current minus 1. Right? Let me think again. If it's negative, then that's a smaller, right? That will be a 0. So we have to have an if check here. Okay. I think we have at least something that we can work with. Let's take a shot. Alright, so first things first, what I want is I think we have to use a vector for this. We call it dp. High plus 1, and then we assign everybody to 0 at the beginning, right? And then we all say for int current equal to, we're gonna go with a minimum of 0 and a 1, and current shall smaller equal to high, right? Because this is eventually what we're gonna reach, and we have to also go current plus plus, right? So this is different length, and we need a res equal to 0, right? So for here, what I want to do is I have a current. We can say current, if current is larger, right? We can say int 0, 0 count, okay, shall be is current larger or equal to 0. If current is larger or equal to 0, then we shall return dp. Oh, hold a second. dp 0 shall equal to 1, right? So if that's the case, we shall say dp current minus 0, otherwise it will be 0, and 1 count is current larger equal to 1, and I will say dp current minus 1, otherwise 0. Alright, so we're done. We do dp current equal to the zero count, zero count plus one count mod. We do have to have a mod. Yeah. Alright, we need a mod. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we'll mod it, and then res will equal to res plus dp current mod. And we'll keep going this, eventually we'll return res. Alright, let's try. The only thing that I am worried about is overflow or something like that. Oh, you should worry about something else, because this is absolutely not correct. Output 14. Dude, that is not good. 14. Huh. That is interesting. 14 is neither here nor there. What in the world? So we go from the small, so current will be 1. 1 is smaller equal to 3. Okay, so zero count is dp 1 minus 1, so that'll be 1. 1 count will be 1. So dp current is 2. Right, and then result is 2. Next current is 2. Current is 2. 2 minus 1 is 1. Right, so that will be 2 plus will be 4. So dp should be 2 plus 4 is 6. Right, next one is 3. Right, let's take a 1, and then that's 4. 4 and 4 is 8. Oh. I see. I see where the problem is. We don't add them all together. I think we shall, should do it this way. And we say for int I equal to low I smaller equal to high, I plus plus, res equal to res plus dp I and mod. Okay, this shall be right. There we go. So it's straightforward. Call it straightforward 2466. dp, where dpi, right, is the total number of ways to create good strings with of size I. For a new dpi, we can either use, use 0, right, first, or 1 first. Each will accumulate dp I minus 0 or dp I minus 1 number of new good strings. Add them together, we get the total number of good strings with size, with length I. Runtime is on, where n shall equal to high minus low. Alright, we're gonna submit it. You don't want to test some test cases. Edge case. What edge case are you thinking about? Well, we can go 1, 2, 3, 4, 5, and a 1. That's something we can do. And we can also go absolutely edge, just everybody's 1. So we run through both. 1 to have value from 1 to 1 only. Okay, which one? Test case 3. Okay, now I need, yes, test case 3. Low, high. I don't understand. What was the issue? Expected 1 to have value from 1 to 1 only. Oh, I see. So it should be 2. Yeah, I know. It's because it has to be small equal to low. Okay, I think this is good. We can submit, and yeah, it's not bad. Okay, we go 1 millisecond. What's this? See, this is the thing that nice. This is a good notification, because sometimes they change. They change the. Oh, you do this just to switch back and forth. I got it. Okay, and okay, I do not like this. Previously, I don't have to reformat it, but now I have to reformat. Seems stupid to me. Tags. What the hell is a tag? Enjoy. I don't know what a tag is. Editorial. Yep, that's exactly what we do. Recursion. I start to don't like recursion in this case. Yeah, you should. You absolutely should. Okay, that's it for today. But we'll move on. I want to do this one. I believe I have a recursion, not recursion, I have a wrong answer for this. Okay, what is the problem is? Build an expression out of numbers by adding one of the symbols before each integer in nums and then concatenate. Oh, you want to find the number of different expressions that you can build, which evaluate the target. And we are saying that we can use, okay, why did I submit it? 26. So we can probably, go to 26. All right, I think I was trying solution 3. Okay, so we have also we have a couple of things that's not working for us. For example, we need target. What we say is dpij is the number of ways to find a sum using only nums from start to I, right? So using only this, I need to find the sum for whatever, and we have two options, and the option is the next one, we can add it, right? If we want to add it, because I have j, right? J goes through all different possibilities, and we want to know, to reach this j, what is the total number of ways, right? What is the total number of ways? And it didn't say anything about going berserk, so I think it should be fine. Yeah, so the number of ways. So I know that j need to represent the total. So we just say, if I want to reach this total, right? So I need to, yes, okay. So basically, we should not use 1000. I think that's one thing. It's pretty clear that I think will be wrong. To find some j plus total, right? So essentially, we have a range. Is the minus, yeah, here, total is the sum of all nums. The possibility of all types of sum is from minus total to positive total. So to this is not true. We have to say 0, okay? And now say for int n of nums n plus equal to n. Okay, so now we have n, and now we do n plus 1. I don't like it. I don't think we should do it that way. I think what we need to do is std vector of std vector of int, call it dp. We'll have m rows and vector of int of n plus 1 columns, and then they initialize everybody to this. So we don't need this. str, that's not right. sd. And then we go through everybody. Actually, that's not true, right? That's not true. All we need is just the beginning, right? So what I need is dp0, right? dp0, and I have the value. So nums okay, so that's actually not right. It's 2 times. Right, so this should be nums 0 plus n, right? It's basically, you have to hold a second. So basically, it's a 0 will be n, right? That's my understanding. 0 index, not 0 indexes, the value is 0. Because if the value is a negative total, or negative n, that will be the 0. So the actual value should be the index minus n, right? Index minus n is your value. So the value plus n is the index. So yeah, so this will equal to 1, because we have one way to reach there. And dp0 n minus num0, that also should be 1. Okay, now we go start from 1 towards m, right? And j will go from this towards 2 times n. So it's going to be the j is the index. We're going to get a value. So to get the value, the first convert is j, the target value. To get the value, it's going to be minus n, right? Index minus n is a value. This is the value minus the number, right? Minus the number, and then plus the value. So option 1, we say j minus this is larger or equal to 0. So this value converts it back to index. I tend to believe it will be larger or equal to. So basically what this means is I have a current value, which is j minus n, right? This is the current value. And we just want to know if this value can be formed in some capacity through n, right? And then we just do minus this to get there, which means just plus n, plus nums I can reach this value. So we say j minus n minus, right, if it's largely 0, I mean, if it's smaller than 0, which is also fine. So plus n is the index, right? So it's the index. So if it's the index larger equal to 0, right, if the index is larger or equal to 0, and I say and j minus nums I is smaller or equal to, well, it should be 2 times n, right? It should be 2 times n. Maybe that's where we got it wrong. It should be 2 times n. But it will always be smaller than equal to 2 times n, isn't it? I'm not sure. I am not sure. But 2 times n is the largest possible, if you think about it. Right? 2 times n is the largest possible. And here we're talking about something plus this equal to the target. Or no, it's just plus nums I, plus nums I. Because there's something added to this, so if it's a minus, or something big, right, and minus this, something big. No, I don't think we need to, because it's already the biggest. So what I think, alright, what I think is I can simply do dpij shall equal to dp I minus 1, because we ended the one before, right? And then j minus nums I. And oh, but we still need, all right, hold on, we still need this. Okay, that's fine. We just do this, and then we do target is the value, right? And the value need to plus n to get to the answer. Alright, is it plus n or plus 2n? Actually just plus n. Because the target it can be n, and then we just plus n. Okay. So we're gonna run this one more time. Let's try it one more time. Can we get some of the test cases as well? Alright, I use this test case. Runtime error, we use this test case. We also have this. Use test case. Oh, this one you already use a test case. And we have this. What do we have more? This. Okay, we have bunch. Try it. Okay, that is just an oversight. Still not used to this one being at the top. We have some correct answer, but most of them are wrong. Zero. Very intriguing. Yeah, we do 0, right? Because at 0 you only have one value, so it's just plus n, right? You set it to 1, set it to 1, and then you start from 1, and you need to go through all possibilities. Let's see. Nums. So 5 ones. 1, 2, 3, 4, 5. Target is 3. Alright, this one will be find target and target. Okay. We're talking about 26. My bad. Having had this problem before. Alright, I don't really care about these two. This num is also not what we care about. What we care about is dp. dp is everyone is 11 because that's 5. Yeah, that's good. And dp 0, I'd expect 5. Oh no, the first one is 1, so 1 plus 5, and 5 minus 1, 1, 4. So basically these, if you want to convert it to values, it's going to be this minus n, right? This minus n, n is 5. Remember, n is 5, right? N is 5. So it's minus 5 is going to be the actual value. Okay, so now I equal to 1. With j star with 0, okay, and then So j is 0. We are saying, can we make -5? Right, -5. So to make -5, I go to dp0, right? dp0, well, actually, yeah, so dp0, we need to go, if I want to make it -5, then what I need is, because j is 0, 0, and -5, right? So -5 minus 1 is -6, and -6 plus 5 is -1. So I cannot get it, right? Okay, so another one is -5 plus 1. Plus 1 is -4. -4. So if previous can be a -4, then our current can do a -1. So I need to find previous -4. But previous -4 will translate to 5 minus 4, so translate to 1, and it's a 0. So currently I got 0. Right, OP1 is 0, OP2 is 0. So it's gonna be 0. Right, so I'm doing this one. Right, it's 0. So this is I equal to 1. And next, j is going to be 1. Right, j is 1. Oh, I can go all even higher. Right, j is 1. So I want to find if I can do 1. Well, technically it cannot, because, yeah, 1 is also not possible. So P1 should be 0, P2 should be 0, and then we get a 0. Next, j equal to 2. J equal to 2. 2 minus 5 is -3. -3 is still not possible. Okay, and then -2. -2 is possible. J is 3. -2 is possible. Okay, J is 3. 3 minus n is -2. Right, -2 minus 1 is -3. And then plus n is 2. Oh, that's not possible. But -2, if I do plus 1. Yes, so LP1 is 0. Okay. OP2 is -2 plus 1. It's -1. Right? And -1 plus n is 4. Right? So that's a 1. So OP2 should be 1. Yes. And dpij, so it's 1, 3 is 1. Okay. That sounds right. And we have to go all the way to 2 times n, which is 11, which is 10. 4 is 1. Yeah, it's not possible. 5 is 0. One of them should be possible. Right, so j is 5. 5 basically you want 0. So one of them should be possible. Yep, the first one possible, second one not possible. That's good. 6 is 1. 1 is not possible, so both are 0. 7 is 2, so one of them is possible. Ooh! We have a problem. Because 7 is 2. Right? 7 is 2. One of them should be possible. 7 is 2. So j is 7. 7 minus 5 is 2. Right? 2 minus 1 6. Ah, I see the problem. Took me so long to figure it out. Now I still think, yeah, I think this is not necessary. It's back to index. Okay, I'm gonna remove this. I think this is not necessary. Just extra computation that's really not necessary. Should be 2 times n. Okay. Because 2n is the biggest. Oh my lord. You do need it. Ha. I guess I was not thinking straight, but this shall be 2 times n instead of n. I don't know why I didn't realize this. I think this I can just do reverse it. 2 times n, and then here is also 2 times n. That, I think, shall be right. Okay, we write on both this, we write all this, and this is the only one that we are wrong. And we are freaking still getting this stupid missing stuff. Right, 1, 2, 3, 4, 5, 6, 7, 8. Should be 2 to the 8th. 2 to the 8 is 256. What in the world? That's what I'm saying, right? You do this, and I shall say plus equal to 1, plus equal to. Then our starting point is 2. There we go. That's the issue. That's the issue. Now we submit it. You're freaking kidding me. What? 1 and 2, which means it's an impossible case. And what do? Oh, the target can be larger than. We should add a edge case here. All right. Basically, here shall be plus equal to, but we shall say if n is smaller than target, then I'll return 0, which means it's not possible to even consider. Right? Well, it's not even possible to consider. Like the maximum sum of everybody is still not able to consider. All right, let's run this. Holy guacamole. Oh, you gotta be kidding me. Oh my lord. Oof, that's tough. That is rough. So n is smaller than target, or negative n is smaller than target. I'm not sure. Can I use I think it's possible. I think it's okay. Alright, this is also an oversight. Jeez. Unbelievable. I forgot that it goes both ways. Addition of unsigned. Okay, something is not right. Oh, my bad. It should be n smaller equal to negative target. All right, come on. Come on. There we go. That's the stuff. It's pretty hard. From the track record, you can see like it was never a very smooth way to get through all this. Right? It's always some issues. I mean, honestly, it's not really that bad. It's just edge cases. Some edge cases. Yeah, this should be negative. I don't know why I do it the other way. Pretty stupid. Okay, this is pretty fast. What's the runtime for this? Oh, I already did runtime. Oh no, n is not equal to 2000. Damn, n is equal to sum of all values in nums. Alright, it's this one. I have to figure it out another way to handle this. This is not working. Dude, this is not working at all. Taking so long just to do this. Alright, we call it. I mean, the DP is fairly easy, okay? It's not a difficult solution. It's just some complications, okay? It's just some complications on how things are supposed to move around, right? How things supposed to move around. That's the one that really gets you, right? Really gets you. Okay, that will be it for this one. I will see you guys tomorrow.